In this example, we're given the first three terms of a geometric sequence, and we are required to find out the term number that would be the first to exceed 1 million. So we just need to write down first whatever we have. So we have our A value of 2. We can also find our common ratio, which we can use the second term divided by the first. This gives us 3. And from here, we want to find an n value that will be 1 million. That n value may not be a whole number, but we can then tweak that a little bit to find out which one would be the first to exceed 1 million. So if we use our rule above, it's Tn, we don't know n, we do know a. So from here, Tn equals 2 times 3n minus 1. Okay, so at this stage here, we're going to substitute Tn for 1 million. And then we're going to work out, or try to work out, what an n value is that corresponds with 1 million. Okay, so I'm going to swap both sides and put 2 times 3n minus 1 on this side, and then I'm going to make this other side here 1 million. Okay, so we're going to divide 2 by both sides. Then we would have 3n minus 1 is equal to 500,000. And from here, if we want to find the n value, we actually should try to log both sides. And in doing that, what will happen is we will get the indice, and that will be brought out the front. So if we go ahead and log both sides, what will happen is n plus 1 and minus 1, will actually come out the front. And we'll still be left with 3. This here remains unchanged. And if we then go ahead and divide log 3 to both sides, we will have then an expression on the left as n minus 1. So from here, we can then just add 1 to both sides, and we will have some n value. So after some calculation, n minus 1 is equal to 11.94. Therefore, n is equal to 12.94. Okay, so with an n value of 12.94, this will get us, there's decimals after that as well, this will get us a direct 12.94th term of 1 million. Now, we know that we want a whole number term, so you might think, do we round up or down in this situation? If we rounded down and we said the 12th term, we would get a result that is less than 1 million. And the questions actually asked us to find the first term, numbered term, to exceed 1 million. So in this case, we would have to say that the 13th term would be the term that we require here.